All right, so we were talking about radioactivity, and we were talking about Madame Curie's bad idea of drinking it, drinking radium. Don't do it. But anyway, we had said we had these three different forms of radioactivity. We have your alpha particles, your beta particles, and gamma rays. And gamma rays, they're just super high intensity radiation. This is what sometimes people, you hear of somebody being treated with radiation and you think, oh, do they glow in the dark? No, it's because it was gamma radiation. They're not being bombarded with protons or anything like that. So that's what they use in sort of medical kind of fields. But these other things lead to what we call radioactive decay. And so before I mentioned the two kinds. I said we have the alpha particles, and the alpha particles we had said they're going to release 2 protons and 2 neutrons, and we had said that high energy and the neutrons are what we had talked about are being used in the nuclear fission process. But just in general, this is a form of radiation where the element, the atom, releases 2 protons and 2 neutrons. Well, if we had said the number of protons determines the identity of an element, so that element changes identity. And in the case of uranium-238, that other form of uranium, we're going to be releasing 2 and 2, so that's 4. So we're going to lower this atomic weight from 238 to 234. And we had said, oh no, we've lost 2 protons, so we became thorium. You became thorium, and then this particle that you released, because it has 2 protons, its identity would be helium. So what happens is in a decay series, a radioactive decay series, then it becomes a smaller molecular weight compound, thorium. Now we had said, what happens, another kind of radiation is a beta particle. And the beta particles are high energy electrons that are released. But there's another piece to that story. After they release the electron, one of their neutrons converts to a proton. Goes the other direction. So this thorium, which emits beta particles, it goes from 234 to the 235 here. I made a mistake. 235, and it adds. No, it doesn't. It stays the same. My bad. It stays the same. So it goes, though, one of those neutrons that was part of this 234 became a proton, so it goes and it becomes, and I have to look this one up every single time. PA stands for, these are compounds, protactinium. Who ever heard of that? But anyway, it's part of the decay series. And so we have this back and forth, getting smaller, getting bigger, and all of this going on with radioactive decay. And you have a really nice figure in your book. It's figure 610, chapter 6, figure 10. Look at it, because this is showing the radioactive decay series starting with uranium-238. All right, so we'll stop right there.